Let's understand what are acids. An acid is any compound that yields hydrogen ions, H positive, or hydronium ions, H3O positive, when dissolved in water. Hydronium ions are really the combination of H plus ions and H2O molecules. That is, the substances such as curd, lemon juice, orange juice and vinegar have sour taste. The sour substances found in nature or prepared artificially are called acids. Acids are of two types: organic acid, mineral acid. Click the buttons to know more about them. Let us understand properties of acids. Corrosive nature of acids. Acids are corrosive in nature. Strong acids can destroy paper, cloth or wood. Acids can also corrode metals such as iron and aluminium. Let's understand reaction of acid with water. Reaction of acid with water is highly exothermic. Click on the exothermic. Let us do an activity to observe the exothermic nature of this reaction. Take 10 ml water in a beaker. Add a few drops of concentrated sulfuric acid in the beaker with the help of a dropper. Swirl the beaker slowly. Now touch the base of the beaker. Is there a change in temperature? Hence, the reaction of acid or base with water is highly exothermic in nature. Hydrochloric acid, sulfuric acid and nitric acid are the most common acids used in the laboratory as well as in several industries. Let us look at the uses of all these acids. Hydrochloric acid. Hydrochloric acid is used in the oil industry to dissolve oil-bearing rocks. Hydrochloric acid is used in the manufacturing of chemicals such as glue. Hydrochloric acid is also used in the purification of salt. Hydrochloric acid is used in removing the deposits called scales formed inside boilers in industry. This is known as descaling. Let's understand sulfuric acid. Sulfuric acid is used to manufacture fertilizers such as ammonium sulfate and superphosphate. Sulfuric acid is used in the manufacturing of detergents, drugs, plastics, plants, etc. Let's understand nitric acid. Nitric acid is used to manufacture fertilizers such as ammonium nitrate. Nitric acid is also used in the manufacturing of explosives such as TNT, trinitrotoluene, and nitroglycerine. Nitric acid is used in the extraction of some metals from their ores. Nitric acid is used in the purification of precious metals such as silver and gold. Let's understand what are bases. A base is thought of as a substance which can accept protons or any chemical compound that yields hydroxide ions, OH negative, in solution. Let's taste a baking soda solution. It does not taste sour, it is bitter. As baking soda does not taste sour, it does not have any acid in it. When we rub baking soda solution between our fingers, it feels soapy. The substances which have a bitter taste and feel slippery are known as bases. The nature of such substances is said to be basic. Now let's understand strong and weak bases. If a base, when added in water, completely dissociates into atoms containing positive charges and hydroxide ions negative charge, then the base is called a strong base. On the other hand, when a base partially dissociates into atoms containing positive charges and hydroxide ions negative charge, then the base is called a weak base. In other words, greater the number of OH ions produced, the stronger is the base. Strong bases such as sodium hydroxide and potassium hydroxide are corrosive and can burn the skin. Mild bases. Weak bases are very mild. For example, milk of magnesia, an antacid medicine that people take to get relief from excessive acidity in the stomach, is in fact magnesium hydroxide, a weak base. Let's consider some uses of bases. Calcium hydroxide has strong basic properties and hence has varied uses. It is used as an ingredient in making lime mortar, used for laying bricks, whitewash for renovating the walls, and slaked lime plaster for making sculptures and decorative designs on the walls. Sodium hydroxide, commonly known as caustic soda, is used in manufacturing soap and paper in large-scale industries. Salts can be defined as: a salt is a compound formed by the partial or total replacement of the ionizable hydrogen atoms of an acid by a metallic ion or an ammonium ion. A salt is an ionic compound which dissociates in water to yield a positive ion other than hydrogen ion, H positive, and negative ion other than hydroxide ion, OH positive. Example: sodium chloride is a salt consisting of Na positive and Cl negative. Family of salts. Some common salts are, let's observe the following. Salts having the same positive or negative radicals are said to belong to a family. For example, Na2SO4, NaCl, NaNO3 and Na2CO3 belong to the family of sodium salts. Similarly, K2SO4, Na2SO4, CaSO4, MgSO4 and CuSO4 belong to the family of sulfate salts. Sodium chloride is used as raw material for manufacturing washing soda, Na2CO3 into 10H2O. Sodium carbonate is obtained by heating baking soda. Recrystallization of sodium carbonate gives washing soda. It is a basic salt. Uses of washing soda. Sodium carbonate, washing soda, is used in glass, soap and paper industries. Sodium carbonate is used in the manufacturing of sodium compounds such as borax. Sodium carbonate can be used as a cleaning agent for domestic purposes. It is used for removing permanent hardness of water. Let's understand plaster of Paris. On heating gypsum at 373 Kelvin, it loses water molecules and becomes calcium sulfate hemihydrate, CaSO4 into half H2O. This is called plaster of Paris. Plaster of Paris is a white powder, and on mixing with water, it changes to gypsum once again, giving a hard solid mass. Only half a water molecule is shown to be attached as water of crystallization because two formula units of CaSO4 share one molecule of water. Uses of plaster of Paris. Plaster of Paris is used by doctors as plaster for supporting fractured bones in the right position. Plaster of Paris is used for making toys, materials for decoration, and for making surfaces smooth. Salt can be defined as: common salt is the refined form of sodium chloride with the formula NaCl. It is also called table salt because it is used as an important raw ingredient. The important sources of common salt are seawater, rock salt and inland lakes. Rock salt. It is a mineral form of sodium chloride, often found in the form of colorless or white crystals with a little brown color due to the impurities present in them. Seawater. It is the main source of common salt and contains a number of salts dissolved in it, most of which is sodium chloride. Inland lakes. By natural evaporation of water, large quantities of salt are obtained from this source. Iodized salt is table salt mixed with a minute amount of potassium iodide. Chlorine produced during chlor-alkali process is used for the manufacturing of bleaching powder. Bleaching powder is produced by the action of chlorine on dry slaked lime, CaOH2. Bleaching powder is prepared by passing chlorine gas through slaked lime. Uses of bleaching powder. Bleaching powder is used as an oxidizing agent in many chemical industries and for disinfecting drinking water to make it free of germs. Baking soda, sodium hydrogen carbonate, NaHCO3, is commonly used in the kitchen for making tasty crispy pakoras, Indian snack, and cooking dals, pulses faster. It is produced using sodium chloride as one of the raw materials. pH of sodium hydrogen carbonate is 2.14. It is used for neutralizing acid. It is a mild non-corrosive base. The following reaction takes place when it is heated during cooking. Uses of sodium hydrogen carbonate. Sodium hydrogen carbonate is used for making baking powder, which is a mixture of baking soda and a mild edible acid such as tartaric acid. When baking powder is heated or mixed in water, the following reaction takes place. Sodium hydrogen carbonate powder is used a lot in making the dough for breads and other bakery products. In making dough, baking powder is added to the flour and then the flour kneaded with water. After making the dough, it is left to rest for some time. The dough rises and increases in size because of the carbon dioxide released by the reaction of baking powder and water. Uses of sodium hydrogen carbonate. Sodium hydrogen carbonate is used in soda acid fire extinguishers. Following is the reaction between sodium hydrogen carbonate and a hydrogen ion of an acid that takes place in the extinguisher, thereby releasing carbon dioxide gas. Let's understand the strength of acidic and basic solutions. Water is slightly ionized into hydrogen ions, H+, and hydroxide ions, OH-. In pure water, the concentrations of hydrogen ions and hydroxide ions are equal. Due to this, pure water is neutral. When water is mixed with acid or base, it results in decrease in the concentration of ions, H positive or OH negative, per unit volume. This process is called dilution, and the acid or the base is said to be diluted. We can quantitatively find the amount of ions present in a solution of acid or alkali by use of universal indicator, a mixture of several indicators. The universal indicator shows different colors at different concentrations of hydrogen ions in a solution. The second way to determine the strength of acids and bases is by using a pH scale. pH scale measures hydrogen ion concentration and indicates acidic or basic nature of a solution. The scale measures pH from 0, very acidic, to 14, very alkaline. Higher the hydronium ion concentration, lower is the pH value. Acidic nature increasing. Basic nature increasing. Increase in H positive or H3O positive ion concentration. Decrease in H positive ion concentration. The pH of a neutral solution is 7. Acidic solutions have pH less than 7. pH above 7 represents increase in OH negative ion concentration in the solution, that is, increase in the strength of alkali. All acids and bases do not ionize or dissociate to the same extent. A strong acid or base is one that completely dissociates in water. A weak acid or base does not ionize completely. Most of the weak acid or base remains in molecular state. One mole of a strong acid HX dissolves in water, yielding 1 mole of H positive and 1 mole of the conjugate base X negative. Strong glow due to strong acid. Weak glow due to weak acid. One mole of strong base MOH dissociates in water to form 1 mole of OH negative and 1 mole of metal ion M positive. Strong glow due to strong alkali. Some strong and weak acids and bases. Let's observe the given table. Plants and animals are pH sensitive. Our body works within the pH range of 7 to 7.8. Living organisms can survive only in a narrow range of pH change. When pH of rainwater is less than 5.6, it is called acid rain. When acid rain flows into the rivers, it lowers the pH of the river water. The survival of aquatic life in such rivers becomes difficult. pH of the soil. Plants require a specific pH range for their healthy growth. Optimum pH for healthy growth of some plants is as follows. pH of the soil. Let's test the pH of soil. Take some amount of soil and put it in the test tube. Add 5 ml water in test tube. Take a universal indicator and check the pH of the filtrate. The universal indicator shows a yellow color. This shows that soil is alkaline. So banana, cacao crops grow well in this soil. Hence, a pH of 6 to 7 is most ideal for plant growth because most nutrients are available in this range. Soil pH is the measure of acidity or alkalinity of the soil. A neutral soil has a pH of 7.0 and the scale increases, so does the alkalinity up to a pH of 14.0. As the pH decreases to 0, the acidity increases. Let's understand pH in our digestive system. Stomach produces hydrochloric acid for digestion of food. During indigestion, the stomach produces too much acid which harms the stomach and this causes pain and irritation. To get rid of this pain, people use bases called antacids. These antacids neutralize the excess acid. Magnesium hydroxide, milk of magnesia, a mild base is often used as antacid. Let's understand pH change and tooth decay. Tooth enamel, made up of calcium phosphate, is the hardest substance in the body. It does not dissolve in water, but is corroded when the pH in the mouth is below 5.5. Bacteria present in the mouth produce acids by degradation of sugar and food particles remaining in the mouth after eating. The best way to prevent this is to clean the mouth after eating food using toothpastes, which are generally basic. Cleaning the teeth can neutralize the excess acid and prevent tooth decay. Self-defense by animals and plants through chemical warfare. A bee sting leaves methanoic acid, which causes pain and irritation. Use of a mild base like baking soda on the stung area gives relief. Stinging hair of nettle leaves inject methanoic acid, causing burning pain. A traditional remedy is rubbing the area with the leaf of the dock plant, which often grows beside the nettle in the wild. The dock plant is alkaline in nature. Let's understand indicators for testing acids and bases. There are a large number of edible substances which are used in our daily lives. Some taste sour and some taste bitter. Curd tastes sour. Lemon juice tastes sour. Bitter gourd tastes bitter. Substances that taste sour have acid in them, and the substances that taste bitter have base in them. But we cannot taste every item to find out whether it contains an acid or a base. For example, if we want to find out whether a soap is acidic or basic, we cannot taste it. It will be awful to taste soap, and it is also very injurious to health. However, tasting is not the only method to find out whether a substance contains an acid or a base. We can use indicators. An indicator is a dye that changes color when it is put into an acid or a base. It gives different colors in acid and base. Thus, an indicator tells us whether the substance we are testing is acidic or basic by change in its color. Turmeric, for example, is a natural indicator that changes its color from yellow to reddish brown on coming in contact with a base. Turmeric is yellow in color and can stain a white cloth yellow. If the yellow stain is rubbed with soap solution, the color of the stain changes to reddish brown. Why does this happen? The soap solution always contains a small amount of chemical called sodium hydroxide, a base. It is the sodium hydroxide, a base, which changes the color of turmeric stain from yellow to reddish brown. Now if we rub a freshly cut lemon on the reddish brown stain, it again changes to yellow color. The lemon contains citric acid which neutralizes the effect of sodium hydroxide, a base. Thus the turmeric stain regains its original color. Substances that change color on coming in contact with other substances are called indicators. Acid and base indicators are of two types: natural indicator, synthetic indicator. Click on the buttons to know more about them.